Hello guys, I want to welcome us to recitation number 9, and it says in figure 1, the winch is mounted on an axle and the 6-sided knot is welded to the winch. By turning the knot with a wrench, a person can rotate the winch. For instance, turning the knot clockwise lifts the block off the ground because more and more rope gets wrapped around the winch. 3 students agree that using the longer wrench makes it easier to turn the winch, but they disagree about why. All 3 students are talking about the case where the winch is used over a 10-second time interval to lift the block 1 meter off the ground. So student 1 says, by using the longer wrench, the person decreases the average force he must exert on the wrench in order to lift the block 1 meter in 10 seconds. That is correct. That is correct. So for torque is force times perpendicular distance. So it's actually R cross F, which is R F sine theta, if you like. So if we already have them theta to be 90 degrees, so the perpendicular distance is like this. So I'm applying a force down here about this, turning this guy here. So my distance and my force, if the torque needed here, say, is 10 Newton meters to turn this guy. So if I'm in a 5-meter distance, I'll need the force of 2 Newton. So that 2 times 5 will give me the 10 Newton meter torque required. But if I shorten my distance to be 2 meters, and I need the same 10 Newton meter torque, I'll need a larger force of 5 Newton. So that 5 times 2 will still give me 10 Newton. So the longer the arm, the lesser the force you need to apply to get the same torque you require. Okay? So student 1 is right for that, for what he said. So let's see what the other student said. Student 2, using the longer wrench reduces the work done. No, the work done is the same. Work done is the same for every time. And using the longer wrench reduces the power. No, work done and power are related. It's just work done divided by time. So student 2 and student 3 are both wrong. Okay, so only student 1 is right, and student 1 is right because according to the options you have there in the question, it's because the torque that you need to pull this guy up doesn't depend on the length of the wrench, because you know the amount of torque you need. So you can use a shorter wrench to generate the same torque. You can use a longer wrench to generate the same torque. But the length of the wrench doesn't really matter so long as you can produce the torque you need to raise that block up. Okay. Okay. Then number 2 problem in this recitation says, if several wrenches all apply the same torque to a knot as shown in the previous problem, which graph best expresses the relationship between the force and the person? So the force is actually torque over R sine theta, if you like. So it's supposed to be an inverse relationship, but because of this sine theta tweaks the graph a little bit. So it's going to be something like this. It's going to be D for this part. Okay, that's recitation 9. I'll see you guys for recitation 10. Thank you.